So welcome everybody to this session at the I2K about bioimage code generation. First of all, I would like to thank Bioimaging North America and Vanessa in particular for organizing this event, for making it possible that we can meet online worldwide, exchanging knowledge about image analysis and here, for example, about code generation. So I will today talk about large language models, and I actually do not want to spend too much time about the theory. I just would like to pick out one particular aspect, which is code generation. So you have a large language model and you speak to it, you enter English text, and then it produces Python code, for example, for opening an image in your memory of your computer. So I will not dive into a large language model technology or how this technique works in detail today. Here I'm basically forwarding you to these YouTube videos from other people or from a talk I gave earlier this year. There you can learn a bit about the theory behind. So I guess everybody has heard now about ChatGPT. We do not have to explain it anymore. What I found quite fascinating in the early days when this technology came up is that you can upload an image and you can say, please segment the nuclei in the blue channel of this image. And ChatGPT internally, there is some mechanics in there, will generate some Python code, will segment the image, will show you the original image side by side with the segmentation. And it will also explain what it was doing. What's very nice about it is that you can read the code, which is actually applied to your data. So it's like not magically a neural network coming up with a segmentation. You can click there on this button on the bottom and read what was actually happening in the background. Obviously, you have to be capable of learning, of reading Python code in order to make sure that no bad stuff is happening here down the road. Furthermore, there was this year a publication by Jimenez et al. Not too long ago, where they were talking about GitHub issues. So GitHub is a platform where open source developers like myself are organizing their projects. And the vast majority of the projects you see here at the I2K, the code base is hosted on github.com, and the developers are communicating to each other via GitHub issues. So for example, here you see there's somebody creating a new issue about a data leak in whatever, and then another developer typically picks this up and will take care of it. And they will discuss back and forth and will find a solution at some point to fix this bug in this open source software. And these scientists who wrote this paper were basically wondering if a large language model is capable of doing that. And it intrigued me kind of because it's super fascinating. So it turned out that back in the days when they tried with a specific data set, that 2% of the GitHub issues they had were solvable by the language models they were trying back in the days. I think it was Claude 2. So it's quite some time ago already. The technology, the language models they tried are already outdated. Here, by the way, you can also read this paper. I highly recommend. So can large language models resolve GitHub issues, even though the percentage of issues they could solve when this paper was written, it was quite low? The answer is yes, they can. And that's very, very fascinating. And this is basically driving a bit the project, or one of the projects I'm presenting here today. So first of all, I would like to introduce two things, bia-bob and git-bob. So BIA stands for BioImageAnalysis, and Git obviously comes from github.com. Bob might be related with a short version of my first name. I'm trying to make myself obsolete by replacing me with AI. So bia-bob and git-bob are basically both capable of generating code for bioimage analysis, and they are a little bit aimed at different scenarios, also a little bit at a different target audience. So if you want to work on your local computer, install a software and work with it, for example, in Jupyter Notebooks, you would go for bia-bob. You install it, and then you can enter code like, I would like to segment cells in this image using Voronoi auto-labeling. And then Bob would generate a piece of code for you, which you can then execute or curate if you see if there's an issue in there. And you might then see a segmentation falling out. git-bob is not running on your local computer, so you do not have to install anything on your machine, which is sometimes a bit complicated. No, this runs in the cloud. This runs online within github.com. So you can basically, in a discussion thread, ask the same question, and it would then come up with a solution like this and also show you results. So the major difference is that the one thing runs local on your computer, the other one runs in the browser, and you don't have to take care of anything. So, and coming basically back to the question, why do we want to do code generation at all? So why does it make sense? Because large language models are often criticized for limited reproducibility. If I ask a language model today and if I ask it tomorrow, does it have the same result? Also, evaluation is hard. If you do not know the correct answer to your question, how can you know that the language model is lying to you, that it's hallucinating or not? But as an example for the reproducibility issue, if you ask, for example, here in this case, ChatGPT, say A, it may say A with a dot. And if you ask again, it may then say A exclamation mark. So it's like the output of large language models is not 100% reproducible. They sometimes do this and they sometimes do that. But if you ask a large language model to generate code, and then you keep this code. You do not ask again for the same code. You keep this code. You manipulate it, maybe you modify it a little bit so that it really fits your needs. You will then have code like this. And this code is kind of guaranteed that it will always output A and like not modify a dot or an exclamation mark behind, because this is like reproducible, deterministic, we say in computer science, code, which will always do the same. So this is from my perspective, the big opportunity language models offer us in the context of code generation, that we basically avoid or circumvent the reproducibility issue, because we will just reuse the code and not ask the language model again for that. And it basically raises first one important question is, how good are LLMs for bioimage analysis? And we thought a bit with some colleagues, we thought a bit about that. And just as one example, you see here a workflow. In this workflow, we start from an image showing nuclei, we binarize it, we apply connected component labeling, we measure the area of each individual of these objects, and then we measure the average area of these objects. And in Python, you can express basically the same thing. And you will see here on top, this is the prompt. So that's what I just said, that we want to implement a Python function which applies a threshold, connected components, measure area, and then the mean area determination. This is basically the English text we pass to the language model, the prompt. And we would like to have some code which does exactly that. And we have a reference solution. This is written by a human. And we know that this does the right thing, because we have some additional Python code unit tests which will test if this code is producing the right solution. So we collected initially something like 57 of these test cases, and there are currently 18 more on the way. So I think there will be an updated version of this benchmark coming out, I guess certainly this year, but maybe in November. And this is also open for contributions. So if you go through this list on this website, if you go through this list and you see a use case missing, you see something that you do every day or very often, but it's not in our list, then please reach out, and you are really welcome to join us. And there is also, you can have co-authorship on the paper if you want, if you contribute, let's say, substantially, like we typically say one big thing or 3 smaller test cases would be very welcome, and we would make you co-author if you join our forces. So coming back to this test case in images, we then pass this to language models, and we basically measure the pass rate. So how often out of 10 cases, how big is the likelihood or the probability that the certain language model passes this test, that the generated code produces the right result. And you see here on the very left, this is reference. This is the human written code. And then there's the first language model, Claude 3.5 Sonnet, and some GPTs. They basically have a likelihood or probability of passing this test of 1.0. So in 10 out of 10 cases, this worked, or 0.9. So basically almost all of that. And if you look more towards the right half of this visualization, you see a lot of language models, Llama 3, Command R, Phi 3, and so on. These are open weight or open source language models, which are not as capable as the big commercial ones. This is something I observe, unfortunately, quite regularly. So you see here that depending on the question and also depending on the language model, the pass rate is different. And you can summarize this kind of visualization like that. So you see here on the left, you see the different language models, and averaged over all the test cases we had, you see their performance. At the moment, Claude 3.5 is leading. It's a language model from the company Anthropic. And then right after comes GPT-4, which is the technology which runs behind ChatGPT. On the right, you see a visualization of these different test cases we were trying. And you see on the top, you see there are some test cases basically a hello world, blunt Altman t-test. These are quite simple tasks, also more related to statistics than to image analysis. The language models can solve quite reliably. And you see on the very bottom, this is often tasks which have something to do with file handling or with a little bit advanced stuff like image deconvolution, which the language models are not capable of doing, like none of these is. So this is kind of quite interesting because we can differentiate a bit between which tasks can be solved well and which not. So just as a kind of an overview. And you see also on the left with the arrows that the first models, again, are the commercial ones where you have to pay for. And then more towards the bottom, I think MetaLlama 3.1405b. It's a quite big model, which you cannot run on your laptop where you need infrastructure from your institute. It's an open weight model, which can hardly compete with the commercial ones, but is the best one we've seen, at least so far. So we know now that to some degree, approximately 50–60% of the questions can be solved by large language models, at least by the commercial ones, by the big ones. And the question is now, how can you improve the likelihood even further? And there's this term prompt engineering. So we would like to provide the prompt in a way that the likelihood increases that the code does the right thing. So first of all, mathematically the right thing, but also that the code maybe uses the right libraries or the code is as short as we want it to be, and less like not like wasting readers' time. And prompt engineering is basically, I mean, the very basic version of it is modifying a prompt until it works. And I brought here this example for you. So this example is now write Python code to open the image data blob-stative and threshold it using Otsu's method. So it's pretty much the same workflow as I've shown before. Apply connected component labeling and visualize the result. And if you ask language model, I think I asked GPT-4 here, it will then come up with this code. And you see on the top and on the bottom, there is some additional explanation. It also tells you a little bit about what this kind of code is doing. If you do not want to have these explanations, you just want to have the code, you have to explain, you have to add this to your prompt. You have to tell the language model to not explain the stuff. I only want the Python code and short comments, maybe. So this would be one solution. The next step could also be, you work with, let's say, 3–4-dimensional big data, something, and you know that OpenCV, this library I'm using here, is not capable of working with these kind of data, but you know that scikit-image, for example, can. So you can then say, here, dear language model, can you please not use this library, but can you use this library instead? And then it will also adapt the code. And this is when you do prompt engineering for code generation, this is kind of a natural task you get used to. Provide as many information as you need. You learned it with time to make the language model more capable in solving problems in a way like you prefer, or like results are falling out which are mathematically correct. This kind of information we are providing here is the context. And if this is very long, we are talking about long context prompting. So if you hear that at any point in time, this is what it's meant, that we provide a long text with a lot of information to a language model to make sure that the output fits our needs. And here we come now to the first Bob I wanted to introduce to you today. So bia-bob is this tool which runs inside Jupyter. And you can, with %Bob, you can say, load the blob-stative image and show it. And then it will come up with a short explanation, and it will also come up with code. And it will then, you can then execute this code, and you will see this image after loading it. And this is the first major message I would like to transmit today, is that if you use this technology for science, and you also in particular when you start using it, try to keep things simple. Ask simple individual questions like what to do. Open a file and show it. There's not so much which can go wrong if you ask tasks like this. And then you can slowly and steadily increase the complexity. I would not, if you have never used this technology before, I would not start with an example like this. So here this time, I'm now saying %Bob because I want to have a multi-line prompt. And I now tell it here, look, please load this image, segment the bright objects, measure area and parameter, show the original image, the segmented image, and a plot of area versus parameter side by side. And it will also produce this code. But you have to learn how to write these things in a step-by-step sense before you can assemble these longer prompts and there will be a successful result. Do not start with this complex story. Start with simple stuff. Also here, if you execute this code, you will then see a result like this. So And I would like to explain a little bit how it's working under the hood. I mentioned already these long context prompts. So what bia-bob is doing, it is not just providing the sentence you were saying to the language model, it is putting some additional information in there. For example, very common sentence, you may read this often when you talk to people who work with language models. We introduce the language model to the scene, to the scenario it is in. Language model. You are an extremely talented bioimage analyst and you use Python to solve your task. It's basically the first sentence the language model will see. Then we provide a lot of Python-specific code snippets. So for example, here for loading an image, you should use this function. And there's also an import statement showing precisely how it works. And you should save the result in a variable. So we are also additionally to what you said, we are providing code snippets like this, and many of them, not sure, maybe something like 50 or 100. And by the end, we also say, can you please, before you come up with a solution, please summarize what you are going to do, make a step-by-step plan what this code will be about, and then write the code. So this kind of step-by-step going through a task is also very common for people who work with language models to make sure that the code, that the resulting code works. This all together is something like 6,500 tokens or words. So you see, we provide a long, long story together with the sentence you were asking for to the language model, and then there's the result sent back. So again, your prompt becomes part of this. This all together we send to the language model, and the language model will then produce code which fits to the criteria in this very general prompt, but also with the question you were asking. If you work with bia-bob, which I have not shown you in very detail yet, you can configure these things yourself. So in bia-bob, it's basically a predefined thing. In bia-bob, you can configure that self when installing the configuration of bia-bob. And you see here also, you are an extremely skilled Python developer. Your name is bia-bob. You sometimes are called like this. You can solve programming tasks and so on. So it's kind of a similar approach. Which I would, if you install it into your GitHub repository, would recommend you to modify this prompt to make it fit well. You can also later in the exercise, when you create an issue and you want to chat with Bob, you can also see here on the very bottom, there are these detailed instructions and you can modify them. You can also read them, which is very nice. So you can basically see, you will upload an image and you will provide an image analysis goal. I would like to segment nuclei in this image. You will then also see these detailed instructions on the very bottom. And you can guess which of those are useful, which not. You can modify them. You can, if you, for example, have a favorite Python library you work with all day, you could put additional hints in there, and then bia-bob would come up with solutions containing this particular library. Yeah, here you also see examples of this prompt there. And then what's also quite a fun, because I think it will be in the future will play a much more important role, even though this technology is a little bit doing baby steps these days, but I would like to show you anyway. You can also provide the image itself to the language model by saying here, Bob image, and then asking what is in this microscopy image. And then Bob or the language model may answer, the microscopy image shows cells scattered across dark background. So it can actually perceive these structures, and it can also guess very often correctly what kind of microscope image, or that it is a microscope image. So the biologist at that point might say, yeah, that's right, that makes sense. You could then ask in the next step what deep learning library in Python could be used to segment the cells. And Bob may propose to use both. Where also the computer scientist might say, yeah, this also makes sense. And then you can ask, please provide code for applying this algorithm to my image. Make sure that the result is a label image of integer type and visualize the result using an animated curtain. And here you may notice already that in order to write prompts like this, you need to have some image analysis knowledge. You have to have some understanding of how typically image analysis is done in Python. So you cannot, thanks to language models, you cannot avoid learning this. But the way to learn it might be shorter using language models. So then I submit this prompt and I get then back, for example, code like this. And if we execute that code, you will then see an animated curtain like that, showing the image, the label image, basically blending over each other, which is, yay, super cool. And again, if you want to make sure that this code is actually doing the right thing and not coming up with like random segmentation or poor segmentation with Stone Age code, you have to have Python programming skills. So when you work with language models to generate code, you must guide the language model sometimes to produce code which is doing the right thing. And therefore, it's very obviously necessary to have at least basic programming skills. Just here also another example from bia-bob this time. You can ask also here, you can ask what algorithms Python packages would be suited for segmenting cells in this kind of microscopy image. And then Bob would, for example, answer that you can go with the watershed algorithm because we are looking at the membrane-stained microscopy image. So here, this is kind of the proof that this language model really sees, perceives somehow what is in this image. It will also generate code. And it will also propose alternatives like cell pose. So also here in this case, when you start a discussion with a language model, paste an image there and first of all ask the language model to express what it sees in the image. Do not like write immediately full notebooks or anything. First ask what's in this image, what do you think, what algorithm could be used, and then in a conversation you slowly develop the solution together with the language model, then it will fit best. It's kind of rare, I would say, that in the very first shot with a long, complicated prompt in an image, that the language model will immediately come up with the perfect solution. And according to our benchmark, it just comes up with solutions that work in something like 50% of the cases. Okay, just showing that again, how to generate a Jupyter notebook with bia-bob. So you can pass this image, and also here you see the same example. At the beginning of the notebook, describe what the image what it is made for. So you have to have the language model expressing in words what the image contains before it then can generate code which fits to the image. So otherwise it would not work. So let's give the language model a chance to speak about what it's seeing before it produces code for processing this kind of image. And if you ask, for example, bia-bob, it will then generate a notebook, and you can scroll through this notebook and see the individual processing steps. And the fact that we have here a notebook which shows intermediate processing steps is part of this long message, which bia-bob has basically built in. It will, when it produces notebooks, it will always produce notebooks with a piece of code, an intermediate result, and an explanation. And then there's the next explanation, the next piece of code, and the next resulting or the intermediate result image. So notebooks from bia-bob will kind of always look like this because it is instructed to do so. Here just it's a bit a technical slide, but depending on which language model you are using, so you see here OpenAI, GPT-4, Anthropic, Claude, GitHub models I would like to highlight, they are for free. And also within Germany, maybe it even works beyond the border, I'm not sure. There's the Kiski platform, you will get a link later, where you can also apply for language model access, and they claim they give access to everybody, at least in Germany, maybe in Europe, maybe beyond. So I'm not exactly sure about their constraints. And there's one thing left, which typically comes then up in the discussions about reproducibility, not in a technical sense, but more in a social sense. Who has written code, when, and why? So if you publish a project, you publish a paper in a journal, and then you have some code accompanied with it in a supplemental material, a reader might ask, okay, was this code written by a human, or was this code written by an artificial intelligence? Or by which human or which artificial intelligence was it written? And when this code was changed from the first version to the second version, what were the intermediate results at that point? So a newer version has like different results like the older version. So what's the difference and how did this happen? When the code was modified, how did the developers discuss this in the context of this modification? So there's like some, I would call reproducibility issues in the process of scientific workflow of code being made. And this is actually Git or github.com can help us with this because it basically keeps a history of projects while they are developing. That's why using Git, using version control for scientific data analysis projects is like good scientific practice, I would say. And if we want to integrate artificial intelligence in our coding workflows, Git can help us with this as well. And this is basically where Git-bob comes into play. You see here on the right, there are two humans. A domain expert, it could, for example, be a biologist, And then the data analyst, the data analysis expert could be a computer scientist, for example. And you see within GitHub or GitLab also is kind of compatible. You see Gitbob sitting. It's running within the computers of this infrastructure. And behind there are service providers like OpenAI and Anthropic and Google and how they are called, offering these different language models to the public. And you, as a domain expert, might now ask, hi, I have data and I would like to measure X, just as an example. The data analyst could then, for example, say, I propose algorithm ALG and Gitbob should do it. So that's why Gitbob comment is basically a trigger triggering Gitbob to do something. So please show us how to do this with Python. And Gitbob will then internally take this question, send it, for example, to the language model GPT-4, and with the response, it will give you, certainly, try this, and give you Python code, which you can then execute, or which it can execute for you actually in the GitHub CI. And then this is why the expert is necessary at that point. You can say, yeah, a box plot is maybe not the right way for this visualization. We should go for a violin plot. And then you can also explicitly say, Gitbob, please ask Claude to do that. So it would then communicate also with the other language models if you instruct it to do so. And it would then come, for example, with a Jupyter notebook containing the code, drawing the violin plot after it was prompted like this. Also, again, the data analyst has to proofread that. So it's kind of necessary from a scientific perspective that somebody who knows what the code is doing has a look at it. And then, for example, if the domain expert has no programming skills, will be happy about the results. And there is kind of this quality assurance done through the human. So this is the major motivation why we have Gitbob and all. Here's just a practical example. So I have an iterative programming question. So here I was creating this like kind of demo example. In the test.py in the playground folder, there's a function that computes the faculty of a number that uses recursion. And it would be great if it was iteratively instead. I can write this in the same message, but I can also just create a new message below. I can say, Gitbob, think about this. And then Gitbob will put a thumbs up below. So you will see a reaction, which basically tells you that it's working on it. It typically takes something like 1 or 3 minutes to respond. And then it will respond, for example, here, this would be the updated code. So you can proofread that. You can then also, again, guide the language model saying, here, look, there's something. I would like to have this variable renamed. Or can you explain me what this for loop is doing? So you can have an additional discussion with the language model about the code it was proposing. And when you are happy with the code, you say, Gitbob, please implement this. And it will then send the pull request to your repository. So if you maintain your code in the GitHub repository, Gitbob might be a good tool to use for you. The pull request then looks like this. So it also summarizes a bit what it's doing here. I was replacing the recursive implementation of the faculty function with an iterative approach and so on. You can have a look at the code changes, how the code was modified. In red, typically displayed the code which was removed, and in green, the code which was added. And this is what is kind of, again, scientifically necessary, that a human is peer reviewing the work which was generated by AI. And this is long-term documented because you can still go through these issues and pull requests on github.com. You can read them years back and see how decisions were made back in the days and which part of the code was generated by AI and which part of the code was written by a human. Just to demonstrate a bit trigger words. So if you ask a Gitbob comment, it will only respond in text form. So it will read your question and it will answer. If you say Gitbob try, it will generate code and it will also run the code and show you resulting images. If you say Gitbob solve, it will generate the code, it will run the code, and it will send a pull request with the code to your repository so that you can make it part of your data analysis workflow. And if you say Gitbob ask ... to ... you can basically combine different language models in one chat. And this is basically what makes it different. So here's an example. And this is what makes it different from the ChatGPT user interface, online. There's multiple people in one thread and potentially multiple language models interacting with each other, solving a data analysis problem. Here, one more example where I, the human, I was modifying code, and I sent a pull request to this repository just for demonstration purposes, obviously, and I asked Gitbob to comment. So it's basically this time the other way around. It's the language model which reviews my code and summarizes a bit the changes. I will not go through all the details, but what I find quite nice is that it basically suggestions. Robert, you should add unit tests for the new functionalities to ensure the work as expected and to maintain robustness. And it is completely, absolutely right with this. I should have done that. So the AI here is in this case reviewing the human work. And it's very nice that we can use this technology also in the other direction. Some more use cases. That's actually my favorite use case. So finish PhD student just before leaving the lab. I will document the code later. Obviously not. So this has happened like a billion times on Earth in so many projects. And I think it's wrong. But what they could say is that AI will document the code later. So you see here an example, Gitbob. It would be great to have NumPy style doc strings for all the functions in this file. Gitbob solve, and then it will send a pull request, adding code documentation. This is such a great tool for kind of eventually writing the documentation for all this code. This also has to be peer reviewed by a human, and the human should also fine tune maybe here and there some words to make this look really, really good. But it takes off a lot of work from the shoulders of the developers of these open source libraries. One more example, both Bobs are capable of doing actually. I see quite often from collaborators these kind of Jupyter notebooks sent around or code in general sent around where there are no comments in at all. And if you, as a particular as a Python beginner, for example, if you get a piece of code, like in this case, it's a simple one, but if you get code sent in a Jupyter notebook and you have no idea what it's doing, it's a pity because from a scientific perspective, you should not run code where you have no idea what it's doing. And you should also not trust the code and then use it in your science. So you need an explanation of these individual steps. So you can here ask Bob, please modify this notebook, add explanatory markdown cells between the code cells, also add a markdown cell at the very beginning of the notebook. And it will then come up with explanations like this, where you can, for each individual step, see, yeah, okay, this is loading the image. Aha, this is visualizing the image, or segmenting it, or measuring something. So it's actually quite nice to use language models to make code more readable. Also, this has quite some potential, I would say, is that you can use both Bobs to translate notebooks to different languages. So I gave a talk at some point in Mexico, in South America, and I was really not aware that we Germans, we learn English in school, and that's why many of us speak English quite well. But obviously, in other countries, English is not like taught in school every day. And that's why when we provide Jupyter notebooks or data analysis with like English documentation, we think we serve the whole world, but obviously we don't, because there are other people who did not learn this language. But language models are perfect for translation. And it's actually fantastic that you can say, look, I have here this notebook in whatever language, and I would like to see it in English, in German, in French, in Spanish, Portuguese, whatever. That's really, really nice. And you may also, depending on which language is your mother tongue, for example, these multidimensional multidimensional image stacks, multidimensional Bildstapel. This is something in German nobody would say. But it is understandable, right? So technical terms are often not properly translated, but it makes it understandable in a different language. That's actually opening gates for like distributing knowledge better over the entire world. Okay, summarizing this kind of intermediate part here and comparing a little bit bia-bob and git-bob. So again, if you work with your data on your computer or on your HPC cluster, if you have direct access to the data and you can open a Jupyter notebook and open a file and do stuff with it, you may want to go for bia-bob and interact directly with your data on your computer. So this is kind of the use case. If you are more into sustainable software development, Python library maintenance, and if you, for example, do not want to work with your data locally or with the software, if you want to use your smartphone and say, hey, Gitbob, can you please? Then Gitbob might be the better solution because it runs in the cloud. You don't have to install anything locally, but you can still execute data analysis stuff. So that's maybe the major difference between these two, local, non-local, and the other one is like bia-bob is more towards image analysis. Gitbob has more use cases, for example, towards library maintenance. Some more examples, in particular comparing with ChatGPT. So you could now say, yeah, but these are all things I can also do in the web interface of ChatGPT or Claude or Gemini or Perplexity. So yes, you can use all three techniques for generating code for bioimage analysis. ChatGPT can additionally search the internet, like also the others, Perplexity and so on. They can all search the internet. bia-bob and git-bob do not do so. If you, for example, look into how bia-bob and how git-bob, how they work, they know what variables and functions you have in your code. They also, in particular, bia-bob knows which libraries are installed in your current environment and can include this information in the context. And that's why it will only generate code which will run on your computer. While ChatGPT may give you a solution using code, using a library which you cannot even install on your computer because you have the wrong operating system. So here they are a little bit in advantage. You can also in bia-bob and also with git-bob, you can involve multiple large language models in one session. So it comes in, from time to time, there comes the point where you have an error, for example, in your code, and you ask the language model, I have here an error, can you please help me? And then the language model comes up with a new solution, which has exactly the same error. It's a bit stupid. So you can go in circles. It will not fix that. And that might be the point where you may want to ask a different language model. Can you please have a look at this code? It was generated by the other language model. Can you have a look at the code and fix it? And then again, the likelihood that it eventually will work is higher. You can involve multiple humans in one session only using git-bob, which is also a big advantage because you can bring the domain specialists, the biologists, for example, together with the data analysts, the computer scientists, in one discussion with the artificial intelligence to come up with a solution. Also cost-wise, just that you get an idea. So depending on which online service you use, you pay between $0 and $20 a month. There are still some free solutions there. But these monthly subscriptions are also very common if you want to have the advanced language model or like additional features. If you use bia-bob and git-bob, you will use a so-called API key. I will later explain what this is. And there you pay something like 5 cents per session or 1 cent per individual call. So that's the order of magnitude, right? So it depends on what you're asking. It depends on how long the context is, the information you are providing, but it's typically in the order of cents. So like potentially much cheaper, depending on how often you use that. Also kind of bioimage analysis unrelated, so that's a fun slide. You can also ask, for example, to write a story about a rabbit in the forest, and it may then come up with this. So it has, git-bob has a lot of functionality you know from ChatGPT, so it's like not so much bioimage analysis related. It can also do a lot of other stuff, just as a kind of hint in which direction this technology may be developing. So git-bob's use cases range much wider than bia-bob's. Some additional words about good scientific practice. I often have discussions about that, and I would like to share here a little bit my opinion. If you use custom code written by, and then you have here two examples, a human expert or an expert large language model. So depending on who you work with, you should do the following. You should understand the code, at least roughly. So I mentioned it already quite a couple of times. You should not just ask a language model to generate code and then use it in your science without ever looking at it. You have to read the code and understand and make sure that it is doing the right thing. You should also, under all circumstances, question used methods. And that's basically true for the human expert and for the large language model. And the cool thing is you can ask both for details. Dear human, dear large language model, explain me why you are using this function here in this line. Both will respond. You have to check results carefully, and you have to test, or you should test the code on samples the expert didn't see. So if you collaborate with a human or if you collaborate with a large language model, you provided some data to solve the problem, and then you should take the code and apply it to other data and measure how good it is. This is like good scientific practice in machine learning, in science, in very general. You should also pay them. So here I would say a human expert may cost something like $100 per hour. And again, the large language model costs maybe something like 10 cents per hour. And sometimes also the cheaper solutions do not have the high quality. You should also mention the expert you were working with. So I would say that if you work together with a human expert who is kind of necessary in your project to analyze the data to make the project actually happening, then this person should be a co-author. There were a lot of discussions if ChatGPT and friends, if they can be co-authors of papers, and I think the community has found some common sense that we should mention the technique in the methods section of our papers. And here I'm really highlighting this, that this is kind of necessary to properly document a scientific project. With a human expert, you can share responsibility. That's why they are co-author. That's why they are on the paper. Because if it turns out 10 years later, or let's say 30 years later, you received the Nobel Prize, but then it turns out that this code was wrong, and they take the Nobel Prize out of your hands, you share the responsibility with the person who wrote the code. You cannot share responsibility with the large language model or with the developers of the large language model. You, as a scientist, are responsible for reading the code and for making sure that it does the right thing. And I would also say that you can ask the expert endless questions, but the human expert may not have as much time. That's an advantage of the expert large language models because they are permanently unlimited patient. You can ask 100 questions to the language model. Can you please explain me the for loop again? Or can you explain me again why this variable here has this value? And it will always come up with an explanation. And again, you should share how you prompted the expert, at least with the language model cases. That would be good in the methods section, for example, or at least with your colleagues. Show your colleagues if you are successful with prompting for code so that others can learn with you. Also, an important note in that context, whatever you enter in bia-bob, git-bob, ChatGPT, Claude, and so on, will be sent over the internet to people you do not know. You should not enter private, sensitive, personal information, secret research information. You should not put in there. That's why keep the information you enter in these models as low as possible. I would like to segment nuclei, and I would like to measure their size or shape. Do not tell the language model provider or the server on the other side what exactly biologically you are working on. That might harm your science. Here I have now some slides about installation, and I will more or less quickly run over them so that we have some time left for questions. But you may, if you want to install the stuff on your computer or on your GitHub repository, you may need these screenshots to look, okay, I have to click here, I have to click there. What is very important to understand when you work with this technology are these API keys. Application Programming Interface is the long name, and I would say it's a modern kind of password. It was basically invented to avoid that you have to enter username and password all the time. So we are using a language model which is located on a server on the other side of the planet. We have to log in there in order to be allowed to use it. But we do not want to enter username and password all day, all the time. That's why API keys were invented. So imagine, for example, you log into, my favorite example here in this context is Google. You have a Google account and you log into Google. And you would like to make your computer use of the large language models at Google, but you do not want to have your computer access to your emails. So you give access to this program using the large language model with an API key, which only has access to some tools on the remote server, only to the language model, but for example, not to emails. So you see here, I'm logging in there and I'm basically obtaining an API key in this online platform. And I take this API key and I save it on my computer. And then the computer can log in using this API key instead of username and password and use these some tools. So it cannot use everything, but it can use these some tools. And that's why it's important that you should never share your API key with others unless you really trust them, because they may potentially spend your money. So using language models costs money. So if you give an API key to somebody, they may burn your money. Furthermore, if it happens from time to time, that may happen that you give the API key to someone and then you would like to make sure that it can no longer be used. You can revoke these API keys typically at any time in the online platform. So if it happens by accident that you shared the API key, you can just invalidate it. Here now these screenshots I mentioned. If you, for example, have an account or create an account at Claude, you can click here on the Start Building button. There's this Get API Keys, and you can create a new key. Similar, it looks at OpenAI. The user interfaces are sometimes quite confusing. So here, please check these numbers 1, 2, 3, 4. That's the order you have to click. GitHub models I mentioned earlier. I think you have to sign up on this website and then you have to be on the waiting list for something like a month. So you have to wait some time, but then afterwards you can get an API key and you can then use these language models, a handful of language models, for example, GPT-4. You can use them for free, which is quite nice. And Yes, that's just another link for if you want to create this kind of token, you can do it there. This is the KISS-Key service I mentioned earlier. That's part of the German infrastructure for scientific computing. So it's kind of a German non-profit organization which offers open weight models on their servers. You can apply for access there. If you are not from Germany, if you are not from Europe and you try that out, please provide feedback. Let me know if that works for you. I would really love to know if this is like they claim here, target group everyone. But I'm not sure if this is limited to Germany or Europe. That's why I would really love to know if somebody from South America, Africa, Asia, if you get access here to these servers, would be interesting to know. Yeah, you have to enter some contact information on their platform and you have to set this radio button here to API access to their chat service to actually make this work later on. After you obtained the API key, which one, no matter what, here the example is shown for OpenAI, you can enter it on Windows in your environment variables like this. And you have to here enter OpenAI key, Anthropic API key, GH for GitHub Models API key in the upper field, and then the key itself in the lower field, dependent on which one you were using. After saving the API keys in your environment variables, at least in Windows, you have to restart the terminal. You have to basically close the application and then start it up again. So if you want to use bia-bob on your computer, that would be the command for installing a Conda environment where it's installed together with some image analysis libraries. You can then activate this environment and you can start a Jupyter Lab. And in Jupyter Lab, you create a new Jupyter notebook. And then you can, for example, here write from bia-bob, import Bob, percentage Bob, hi. And then Bob will answer you and will ask for more details. So you can be friendly, but you don't have to. There's also a website where all these steps are explained again. So if it was now too fast, you can read this up again. The GitBob installation is a little bit simpler, even though it is also more technical, I would say. So in order to install GitBob in your GitHub repository, you have to upload a text file. And here you see just a part of this text file. I would recommend here entering a version of GitBob, for example, the current version, just to avoid that updates on GitBob break anything in your repository, just in case. And you should, I mentioned that earlier, you should modify the system message to your use case. So if you, for example, want to use GitBob for generating stories for kids, you can write that here. You are a nice storyteller. You create nice images showing cats and forests, whatever. If you want to have this tool as an image analyst, you should mention that. You should say you are an extremely skilled Python developer and bioimage analyst. And then it will act in this way. Furthermore, you have to also add here the API keys. These are here called repository secrets. So you can here enter the OpenAI key and then the actual value below. And you also have to set the so-called workflow permission so that it's actually executed within GitHub, that it will then actually respond to your task. So this is the installation instructions for GitBob. Also here, it's on the web described in very detail with some examples and so on. So you can also read that in more detail. I was also recently upgrading the code so that it's compatible with GitLab, so you can install it in your local institute infrastructure. So also here, feedback would be very welcome. If anybody tries that out and struggles, please let me know. I would love to update these instructions so that it better fits to the community's needs. So I prepared some exercises you can then do basically as a homework. And one example I would recommend you trying out after installing GitBob on your machine. You should use a Conda environment where, for example, Esperanto is not installed. And if you say, I would like to segment the nuclei using Voronoi auto labeling, it will then come up with this long code, blah, 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 a lot of stuff. And this potentially might result in the right segmentation, potentially not. And then you install Esperanto, you restart the Jupyter notebook, and you will then see it is now proposing Esperanto in a single line doing all that. And this is basically what I was telling earlier. bia-bob knows what's installed. bia-bob knows how to use these libraries, and it can guide you, but you have to install the stuff first. By the way, if you want to learn more about Esperanto, Stefan Rigaud will have a session on Wednesday. I will also join him, help a little bit out about Esperanto and GPU accelerated image processing. Here, just some advertisement for this session in 2 days. And then That would be the exercise for trying out bia-bob. So you can go to this website and you can click here. You do not have to install anything. You just go there and you create a new issue. So you can, for example, upload an image and a scientific question. And then I will, together with you and the artificial intelligence, try to solve this issue. So it's an interactive exercise where I will join because I basically have to tell bia-bob that it should respond to your question. It's basically a security measure. You can also, if you want, you can also ask about a nice story with a nice image, a nice kid story, just to demonstrate that this technology is capable of much more than image analysis. So yeah, here you are welcome to join and create a new discussion, and then we can discuss together with the language model. So let me just summarize before I come to the questions. So very obviously, large language models can generate code to analyze biological microscopy images, and we can learn how to use them. So it's some work and it takes some time. But from my perspective, it makes a lot of sense to use this technology and to learn how to use it. So we need to understand image analysis, and we also have to have some basic Python coding skills in general. We cannot just use the large language model to generate code and assume that it's doing the right thing. We have to learn some basics, otherwise this will not work. I would like to thank some collaborators and also in particular the contributors to this benchmark I was mentioning earlier. By the way, on the right, there's the link to the slides. You can download them and you will then find the link to the exercises in there as well. Good, thanks so far. If anybody has a question, you can raise your hand now and then unmute yourself. Otherwise, I will go through the questions in the chat. Okay, so the first question is what input image formats can these models read? So the language models I have tested, which is the commercial ones are OpenAI's GPT, Claude from Anthropic, and Google Gemini. And there's also an open weight model I was playing a bit with. It's called Lava, and you can use it with Ollama. It's an open weight model, so not as capable as the others. They commonly want to have two-dimensional images, RGB images, in formats like JPEG or PNG or GIF files. So that's technically what it requires. If you, for example, use bia-bob, bia-bob will take care of the conversion of the data, but it's unfortunately two-dimensional images only. And for example, it cannot be like an image with 4 channels because we do not easily know how to convert these 4 channels into an RGB image so that the language model still understands it. As a recommendation, I would say use two-dimensional images with just 1 channel and ask potentially the language model, ask it potentially multiple questions. So provide it the first channel with some membrane staining and say, look, this is the one image. I would like to segment the cells here. And then you provide the other channel independently, where there are the nuclei imaged or some other structure in the cell of interest. And you can say, here, this is the other channel, and I would like to segment those objects too. So that the language model has some idea that you have 2 channels with different information, and it will use this information in the code it generates. Okay, the next question is, did you fine-tune your large language model on images, or is this just an API wrapper? This is just an API wrapper. Again, what I'm using most these days is this long context prompting. So we basically provide all the information which might be useful for segmenting the image or for processing the data in this very long prompt. So this is the technology we are using. I'm also fine-tuning language models. I was during the summer doing quite a lot. It's not trivial. So you can really spend some time and generate a lot of language models which are not capable of doing anything. Then there is again a question about the example workflows which I tested. So you can download the slides. And from the slides, where I show an example, there's commonly in the very most slides, there's a link on the very bottom. You can click on that, and then you can see, for example, all the 2 test cases for the benchmark we were trying out. So you will find a link there. You can go there and have a chat. Create a GitHub issue if you want to contribute something, and then let's have a discussion before you spend a lot of time in something that may, for example, not be relevant at all. Okay, and then I was pointed here also that there is also a QA section. which I do not see. Yeah, so we have to use the chat. If there are more questions, please ask in the chat. No, I see the QA. There's one question. There's another question from an anonymous participant asking, Gitbob can also help write the results of the analysis. I'm not exactly sure how I should understand this question, but if you are asking, for example, for writing the results section of a paper, yes, it's a language model. So if you provide, for example, a plot, or if you provide a table with numbers to a language model and say, here, can you please help me describing this data, it will do. But it might not have enough context to do this scientifically correct. So again, I think most journals now say it's okay if you use language models. Also, funding agencies say it's okay if you use language models and grant proposals. But you as a scientist at the end are responsible for the content. So if this language model comes up with a sentence that is complete bullshit and you submit it to wherever, a journal or a grant agency, you may then see the consequences and it's your fault. It's not the language model's fault. That's why I would actually recommend using language models for generating text and having an idea how some results can be described in a clear and concise way. But at the end, you must make sure that the content is actually correct. Awesome. There's one more question in the chat. Also a very interesting question. So to what degree can we fix the open models using, for example, prompt engineering techniques so that they are better and then can compete with ChatGPT and Claude? My experience is very limited, I must admit. So I did not spend a lot of time here. But I have the feeling that the commercial, the big ones, the models where we are paying money for are really much, much better than the open weight models. And that's why you can spend a lot of effort into making an open weight model through prompt engineering techniques in particular better. But you may not achieve the performance of the commercial ones like at all. Also, it's a lot of effort. What is scientifically quite interesting in this field, and there's also a lot of happening, is so-called knowledge distillation, that you basically try to squeeze out all the knowledge about image analysis, for example, from the big models, and you fine-tune a small model, a small open weight model with this information. I have the gut feeling that this works well. But I'm not at the point where I could exactly share how. So I've done quite some experiments. It looks very promising, but I would not expect like this now in 2 weeks an open weight model comes out, which can compete with GPT-4 or Claude. So this may take some time, but I think the work in this direction is really, really useful because we could come to a point where we can use small models on our laptops and protect privacy because we do not have to send anything to the server of an American company or company anywhere in the world. So I think that will be very useful. I think this technology will come, and I think it will take some time. Good. If there are no further questions, we are perfectly done in time. If you do these exercises and you have any issues, please create either a GitHub issue telling me about it, or you go to image.sc, create a thread there, and you can tag me with my username, which you will also find in the bottom of all of my slides. Thank you all very much for being here, and also thanking again Bina and in particular Vanessa for organizing this event, and see you in the other sessions. Have a great day.